Ferdinand from our proof team. Ferdinand, if you are in the green room, we are ready for you to take over and get us into our second part of our presentations.
I think I'm sharing.
You're looking good.
All right. Okay, perfect. All right. Well, hello, everyone. Good morning, good afternoon. My name is Ferdinand Perez. I'm a product growth manager here at Prove, and today we're going to be talking about our new solution, Prove Unified Auth. So we'll be talking about identity and access management and authentication, but really around really focusing on digital trust, right? So how do you prove that a user that is onboarding your platform is who they say they are? And then how do you continually identify them every time they come back to your platform? How do you do that securely? How do you do that passively? How do you do that at a lower cost, right? So I have a couple of slides and we'll jump right into the demonstration. But I mean, fundamentally, a lot of the authentication infrastructures have flaws, right? I mean, we all know around SMS infrastructure flaws, not being end-to-end encrypted, and just the costs of sending SMSs around when it comes to MFA, as well as just, we thought that maybe passkeys would be a panacea. And, we're part of the FIDO Alliance and we love passkeys and we think that they're a great single factor. But, the issues with syncing passkeys and we're starting to see some ATO type attacks with them have kind of made them a little more difficult to implement. But it's really not about the authenticators. It's really around being all these different fractured or fragmented solutions that you're trying to patch together in order to get really good signals and data around, your users coming back to your platform. So you find it really difficult to recognize returning users instantly, if they're coming from a browser or they're coming from a mobile device, and it's just causing friction. It causes friction where users are not coming back into your platform because they're getting an OTP somewhere or what have you, and you're just seeing lower conversion rates. So what we're really trying to do with Unify, with the unified solution, is to bridge that gap, right? So just imagine enrolling a user once into your solution or your platform, and no matter where they're going, you're always going to recognize them everywhere, from a browser to a mobile device. They change their phone number, they get a new phone. We're talking about a passive and persistent solution that just recognizes them across their sessions, devices, life cycle changes without friction. And that's really what I'm going to be talking about here today in my demonstrations, and I'll take you through a few of them just to illustrate how it will work. Starting off with the burdensome onboarding of somebody into the platform, into your consumer app, right? To a user who's steady state using the app, and then maybe they lose their phone, and how does that affect getting back into the platform? And then lastly, we can go through a more advanced technique, which would be maybe like a ATO of a passkey, right? So we'll go through a few of these different scenarios and kind of drive home a little bit of how the unified approach would work. So here, if we kind of take a step back, I'm Tim. I want to use your solution. I found it great, so I want to come in and enroll, right? So I go to your browser, or I go to a mobile app. And typically you would enter in an email address or a phone number, and then you would get a form, and Tim would have to go and fill that form out. Sometimes that's frustrating. It takes a while. You end up getting a lot of abandoned carts or users just abandoning the service. That's not the case with Prove, right? We can, in milliseconds, be able to onboard Tim into your platform. So verify their identity and then onboard them into your solution, right? Securely. So in this case here, you're just providing a date of birth, and I'll kick this off. And you can see on the right, we've slowed it down, but what it's going to do is it's going to do a silent SIM authentication in the background, right? So we're going to validate the phone number and Tim's possession of the device. Then we're going to look at the reputation. So how long he's had the phone number, if it's a VoIP number, if it's a landline, and then lastly, ownership. Is he actually his name tied to the phone number? At that point, we could pull data, like an authoritative source data, and pull that data back. And now, based off of that one date of birth, we're able to pull all of Tim's data back into milliseconds, and then create an account for him, right? So just really speeding up that process and reducing friction, but keeping it secure, right? So this getting them onboarded. And at this point, what we end up doing is we're going to drop what we call a proof key, a cryptographic key in the secure enclave. And this is a key that we use for part of our persistent trust, right? So Tim now is going to create his account. We're going to drop a key. They're logged in. And now the happy path is when Tim comes back, because the device hasn't changed and that key is still intact, we'll go through our automatic waterfall of looking for that proof key, the cryptographic key on the device. The key is there. We'll also look at phone intelligence. So phone data, is the SIM had been swapped? Is there any fraudulent risk to that phone number? And then at that point, would pass back and say, hey, this looks like the same phone. This looks like the same user. You can log them back into the app, right? So that's very straightforward, steady state. Let's say Tim loses his phone, drops it in a lake, or gets a new phone, right? This is usually a huge burden, right? Because it's account recovery. So now I have to go through this whole process. With Prove Unified Auth, it's a non-event, right? So Tim gets a new phone, gets a SIM in the phone, downloads your app, goes to log in, and what happens, right? So again, on the right side, first we'll check to see if the key is intact. The key will not be there because it's a new phone, but we'll continue to waterfall through other signals and authentication methods. So we'll go and look at the fraud policy. Has the SIM been swapped? It hasn't been. Let's do a SIM authentication. So we're going to authenticate the SIM on the device silently in the background. If that passes, we'll rebind that key, drop the cryptographic key again, and then Tim gets logged back into the app. Obviously, we slowed it down on the right side, but this is happening in seconds, right? So this phone event, this new phone or lost phone event that used to just be a pain is just a non-event now in our platform. Another scenario we go through, like with passkey. So we were actually talking with a few customers around where, passkeys, because they're you can synchronize a passkey. They're just seeing a lot more fraud with it, right? Especially if it's a single factor. So somebody's either, socially engineering them by giving them a QR code to scan, or they're airdropping the passkey from one device to another. How would that work within the Unify solution? Now, again, like, we're easy to integrate, and we will play nice with all different types of authenticators. So it's not, just our solution, right? We're trying to set up a framework where we're going to leverage all of these different signals and authentication keys together in order to solve a lot of these difficult challenges, right? Because just one authenticator doesn't do it together, right? It's a combination of phone intelligence and these authentication keys that are helping us to get back to a trusted state, right? So I've socially engineered Tim's passkey. I have it on my phone now. So this is my phone. I downloaded your app. I go and click on use send with passkey. So this is going to work, right? The passkey is going to be valid. But what's going to happen next, it's going to go look for that proof key. And the proof key is not going to be on the device. And it's going to slowly walk through the fraud policies until it gets to SIM authentication. And that's going to fail on this device. And that would be a sign coming back to you that this is not Tim's phone anymore, right? This is somebody else's phone. And at that point, you could, I'm blocking it here, but you could, set up a higher risk, maybe a little bit more friction, have them call in. But in this case here, really just kind of just blocking it just as a demonstration. But really, what I really was just talking about, it's beyond just single authenticators, single signals, but just really bringing all of those signals, right? The different authentication keys, authentication methods, and phone intelligence signals together in order to handle a lot of these different types of authentication methods, right? So really trying to really reduce the authentication burden when it comes to SMS OTPs, right? Because now you're trusting these devices more and more, so you don't have to send an SMS OTP. Since we're not sending SMS OTPs, there's less fraud. We're also able to identify when there's SIM swaps or possible account takeovers, and then just less friction, right? The users are coming back to your platform, whether it's in the browser, whether it's in an app, and they're just seamlessly getting logged in. So that should be improving conversion rates overall. And with that, any questions? I don't know if any questions came up in the chat.
They did. We'll get rolling. A couple have come in pushing the one I was about to read. All right. For unified auth, in your new phone scenario, you said mobile auth was used. Are these the same limitations still there? i.e. likely require instant link, or has mobile auth evolved?
So mobile, so there's still the same limitations of the carriers that are supporting mobile auth. There's definitely more support for mobile auth these days, but there is a fallback to instant link if necessary. But yeah, those are still there. So that's like I think 80% of the phones in the US will support mobile auth, and then I think you would have to sign a contract with AT&T to get the upwards of 90-something%.
Okay. Oh, we got more. All right. How does the sign-on verification work? Does Prove work with local telecom for the verification? When you said dropping the key to a recovered phone during account recovery, does it mean dropping the private key? How is the private key stored?
Yeah, so the private key it's a cryptographic key that we're creating. We're storing that in the secure enclave in both iOS and then the secure element on Android. So we're just following the best practices to store that key.
All right, and one more. How are syncable passkeys being used as an attack vector?
Syncable passkeys. So syncable passkeys. We talked to a couple of customers where there's because they're syncable, people are getting access to like their iOS accounts and being able to take that passkey off and using it with another service. Also seeing just being able to just airdrop the key from one phone to another. So those would be just some of the threat vectors. So primarily somebody getting access to the actual iCloud account is what I've seen.
Okay, and more questions. We'll probably one or two more, and then we'll let you off the hook here. If fraud occurs after enrollment somehow, is there a way to report it, mark the transaction device, etc.?
So if there's fraud, I guess I would have to see how it would be fraud against the phone itself. I might have to get back to like how the fraud is actually happening on the device to be able to report it. So I guess to answer the question, or maybe hopefully this answers the question. So anytime that the user is logging in, or you can call the unified API, it's going to run through that cycle. So if it's a login, you could do it midstream if it's during a transaction, or maybe you want to do it like, I don't know, every hour or every week. You would be able to run through that cycle, and you would it would be alerted to at that point in time. So it's always checking to see if the proof key is intact, and then cycling through the other waterfall. Yeah.
Perfect. Thank you for running through those so quickly. Folks, feel free to, we can follow up if necessary, but you got to all the ones in the questions channel, so I very much appreciate it. And thank you for the demo.
Yes, thank you, Ferdinand. Excellent demo.